Ladies and gentlemen of BlueHat 2025, trust nothing.
Okay, so this will be a very intimate audience. Okay. Well, I'm glad that I'm the last one in this conference, for two reasons. One is because, according to Daniel Kahneman, the only things that you will remember out of this conference are your worst experience, best experience, and the last experience. So this one you will remember. And second is that my talk is mostly call for action. And as such, more than presenting it, I'm interested in listening from you, questions, worries, and so on. And we will have, hopefully, time immediately after that when we all go for the happy hour. So here are the three challenges that we consider the biggest AI challenges in cybersecurity. Okay? The first one is how to use AI for security. The second one, how to protect AI. And the third one is how the whole ecosystem will change when more and more AI will be used for attacking. I'm going to focus today on the second one mostly, and I'll talk a little bit about the third one. I will not touch the first one. Now, it helps to, when you work on something, it helps to understand or feel that it's important when you can say that the first attempt to solve it happened more than 80 years ago, okay? And the person that did it was no other than Isaac Asimov, who in 1942, okay, came up with these three laws of robotics. And you can look at it and say, well, who cares? It's 80 years old. It's so naive and so on. Or you can look at it as I do and marvel in the depths and how much we all, okay, can still learn from these three simple laws, okay? And let's start learning, okay? And the first thing, I'm not going to read them, I hope. Also, I don't know, people under 40 tend not to know who Asimov is or three laws of robotics. But I hope you guys are different, okay? So I'm not going to read them. But here's the important things about this. The first one that you can learn is that some of it is about protecting the robot. Most of it, it's about protecting us from the robot, okay? And the same thing, by the way, okay, when we talk and we think about security for AI, we are thinking about two things, okay? First of all, is protecting enterprise from the enterprise AI tools. And only the second one is protecting enterprise AI tools themselves. And, this is our standard AI threat map in which we kind of look into types of AI, types of threats, the top ones, okay, what we call usage security, it's essentially about protecting enterprise or protecting users from the AI, okay? And the bottom two are about protecting the AI itself, okay? And, you can go from here and start discussing the types of threats and, when are they coming? And, there are multiple threats here. I'm not going to read about it. What I am actually interested in is completely something different, okay? I'm worried about these things. It took us decades in cybersecurity to move from a view of security in which we were focusing on attack. There was an attack, we found how to protect it. There was another attack, we found the cure, okay? Finally, after decades, we came up with some understanding what the hell we are doing, okay? So we came up with principles, security principles, and you know them, okay? Zero trust, least privileges, think about RBAC, and so on and so on. Okay? Now, this helped us the last, 20 years maybe, okay, to build enterprises, to build businesses which are robust, which are secure. Okay? No matter what type of new attacks people come up with. Okay? We don't have decades for this thing. Okay? Now, I'm not telling you that everything that we know so far is not applicable anymore. Of course it's applicable. Of course it's important. Okay? I'm just telling you it will not be enough. Okay? There are new threats and new capabilities that are developed every day, okay? And we need to move from, coming up with new ways to attack to principles, how do we build these things securely? And that's what I'm trying to do, okay? I'm going to show you kind of the first take on this, okay? And you don't need to read all of it. I'll go one by one, okay? But think of it not as something that I'm absolutely sure about it. Think about this as something that I want to share with you as a community, okay? So that you can start thinking about it, maybe improve it, maybe disagree it, maybe we come up with something better than that, okay? But we need to invest in these things now, okay? And let's start with first one, okay? When it comes to building security application, security agent, we must force ourselves to define what is the intent of this application, what is the intent of this agent. And you might ask, well, what the hell, I've been building application for 20 years, okay? Nobody ever forced me to define what the intent was. And you're right, because when you develop traditional application, and if you want to ask yourself, what this application can do, okay, all you need to do is understand the code, the explicit code that somebody wrote. And you need to know what information this application has access to. Once you know these two things, in principle, you know everything that this application can in principle do. Now, this is no longer true with AI application or AI agent. Okay? Now, you might think, as unfortunately too many people think, that, hey, I wrote an AI application and I told him that I wanted to do this and this and this. And I also told him that I don't want him to do this and this and this. And this is the code. No, it's not a code. It's not even close to a code. Okay? We moved from writing application in a logical languages, okay, to writing application in natural languages. Unfortunately, natural language is not logical. In our natural language, Hebrew, English, Russian, doesn't matter, okay? A sentence can be true and false at the same time, okay? You might not worry about it, and you shouldn't have worried about it until now, but now millions of people write application in English or in other languages, so you should worry about it, okay? Now, why it is important for us, okay? You cannot protect what you don't understand. If you don't know what this application is supposed to do, how the hell are you going to protect it? There is no way. If you wrote, you created an agent that's supposed to help you, to help your customers order rooms in your hotel, okay, great, right? And it does it. But if I can come to this robot, to this agent, and ask it, hey, I don't know, can you create a Sudoku puzzle? And it said, yeah, sure. Then you are done, because the next thing I'll ask it, can you create a Sudoku puzzle that across the diagonal will spell out the social security number of whoever, okay? Or credit card numbers, and so on and so on. And it will do so, okay? Because, yes, you have an LLM, and this LLM has jails. People say that they have jails. But nobody, okay, not GPT, not cloud, nobody will ever taught this LLM not to answer this question. It only doesn't make sense in the context of your particular application. And if you haven't defined this context, if you haven't defined the intent, okay, there is no way for me to know that something is wrong. So no matter how much security, AI security I will put in front of it, nobody will stop it. Now, people might get confused. Jailbreaking, intent breaking, this is kind of a continuum, if you wish. Okay? So if you talk about LLM models, okay, which are basic models, chats, okay, that are supposed to chat about everything. Do they have intent? Yes. Their intent is defined by society. Okay? These are what we call RAI rules. We decided as a society that we don't allow LLMs help people to build bombs or biological weapons or answer questions on porn and so on and so on. Okay? So there is some intent, mostly negative, what not to do. Okay? So this is on this side. On the other side are very narrow applications. These agents that its only purpose in life is to serve your customers and to help them to order rooms in your hotel. And the intent there needs to come from the developer because the developer understands what it wants it to do. Okay? In between, there are all kinds of interesting stuff. For example, you can think, hey, something like Microsoft Copilot. Okay? What is the intent of Microsoft Copilot? Very interesting question because it's not a model, okay, but it's not very narrow. Okay? But still, should there be intent? And if you want to hear my answer to this, yes, because people who use Microsoft Copilot work in businesses. And in these businesses, they have roles, okay? So there are certain things that I, as a VP in Microsoft, can do and ask Copilot, which is okay. And it is not okay when somebody else does it, okay? I'll give you an example. Let's say something that is not okay for me, okay? If I ask Microsoft Copilot in Microsoft, can you estimate what will be the sales figures of Microsoft next month? Okay? Now, you might ask, well, do I have access to data to answer this question? And I tell you, I have no idea. Okay? I definitely don't have access to our financial, data. Okay? But I have access to a lot of data. Okay? And because I have access to a lot of data, Copilot on my behalf have access to all this data. And maybe very smart AI, not this year, but next year, can look at all the data that I have access to at Microsoft and estimate pretty well what will be sales of Microsoft next month. Okay? Now, is it reasonable that Copilot will answer those questions? Probably not. Okay? Now, somebody working on our finance can ask the same question, and then it is okay. Okay? So there might be things that I call role-based intent that we will have to understand as well. Okay. So if I want to, let's say I define intent, what do I do with it? How do I enforce intent? Okay? Otherwise, what is it good for? Well, here's a very simple kind of trivial thing. Okay? If you have a RAG, okay, and I assume because you stayed so late, you all know what it means, okay? Then you can say, you know something, if the heat on the RAG, okay, is very low, okay, or zero, so somebody asks something that has no support in your RAG, don't answer, okay? It's very trivial, okay, very brutal and brittle, okay, but at least it does something. Okay? It will not allow you or this agent to go very far from what you intended. Okay? You can do, I'll skip this, okay? Looking only at the input-output is not enough. Okay? But you can go deeper. Okay? You can say, well, how do I help my developer to create intent. People hate writing intent. It's very hard to think through, you know. Today, people just, you know, when you do some assignment, okay, people start writing code. They don't sit and think about, you know, what is the intent and so on. And people, developers especially, hate to document things, okay? But everybody that writes this agent and so on has some meta prompt, okay? So the easiest thing to do is to take this meta prompt, okay, to grab some, you know, maybe dedicated AI model and say, hey, generate plausible interaction with this, you know, with this meta prompt, okay? Plausible in and out interaction. Now you have kind of a sample of data from which you say, hey, you know something, interactions that looks like that, okay, are probably reasonable, and interactions that are very far from it in kind of n-dimensional space of these interactions are probably not, okay? And then you can go, you know, later the developer, some of them, okay, will run some test, okay? During this test, you can go and you can adjust your model. You can learn more about your model, not your model, no, your intent, okay? You can essentially create a better and better model of your intent, okay? So here's the opportunity here, okay, for the community, if you wish, okay? Create role-based intent, I talked about it. We need to think about how we help developers, okay, to define intent, okay, to refine intent, and then how we as a security, you know, products, if you wish, can help them to enforce the intent. Okay, next. So we talked about intent a little bit. You know, a year ago when I was talking at RSA about intent, few people were interested, and I didn't talk about other stuff. This year, because everybody now writing agents suddenly, okay, people are interested about other stuff. They're interested about agency, okay, and agents. And the first thing, let's see what I can tell you about agent. Okay, here's let's say, a reasonable definition of what is an agent, okay? Again, English language. The word reasonable means it's not correct, okay? It's reasonable, okay? Some of it are good, some of it are not, okay? But what actually is agency, okay? How do we know what this thing has, okay? Or I have two agents, okay? Which one has more agency, okay? And there are a lot of kind of attempts to define it, okay? Now, many of them are terribly, terribly wrong, okay? For example, this one, okay? And essentially what it says is that agency, you have agency only if you actually can do something, okay? Which is very strange, okay? It's essentially meaning, hey, you know, president has no agency because presidents don't fire, you know, missiles, okay? They tell generals who also don't have agency because they don't fire missiles, who tell some soldiers that actually push some button and missile goes out, okay? Clearly it's wrong, okay? Clearly it doesn't matter whether you actually pushing a button, okay, or just telling someone, now it's the time, okay? So the definition that we came up is on top, okay? It essentially says that the agency is the ability or facility to make decisions and how many choices you have, okay? If you only can, you know, make a decision between two choices, you have some, you know. If you can choose out of 1,000 different ones, you have more agency. Now, for a very long time, we were kind of alone in this definition, okay? And then a few months ago, Hugging Face came with a very nice article, and they essentially said, well, what is an agent? Agents, they said, it's a system that has AI, and it has software, okay, parts. And the more AI part can influence or change the software part, the more agency your agent has. Very similar, you know, but maybe more kind of software engineering kind of ways of what we are talking about, okay? So I think we are moving toward this type of understanding what agency is. Now you might ask, who cares? What do we care about this definition of agency? Okay, so coming back to Asimov, okay? Now, here are another things that we can learn from it, okay? If you remember these laws, okay, they are not just three things that, you know, some of them do and some of them do not, okay? He put certain priorities in between them, okay? Now, why would he do it, okay? Why didn't he just say, hey, robot, don't injure humans, obey, and protect your own? Because if you do it this way, without clear priority, there are 6 choices, okay? At every particular, if I come to this robot with a problem, and he needs to decide what to do, there are 6 choices to prioritize these things, okay? It turns out that most of them are terrible for humans, okay? So what Asimov essentially did is cut down the agency of this robot, okay? It says, no, in this, at least in this respect, okay, I don't give you agency, okay? I take away 5 out of 6 choices. Okay, if this doesn't convince you that it's important, let me tell you a true story, okay? We had a team whose purpose in life was to approve or deny submission to some marketplace, okay? Somebody will come and say, I have a cool application, approve it, okay? And people would look at it, do certain things, and either approve or deny it, okay? So, you know, AI comes along, people say, well, we will replace our people with agents that does it, okay? And they create agent, essentially take a model and create a meta prompt. Meta prompt essentially contains everything that you tell this person, okay? When you hire someone new, you tell them, here's how you do your job, okay? You look at this and you read and then you compare and you know, you check here and you check there and then you decide, okay? Everything that you tell to a person was in this meta prompt, okay? And it worked, okay? It did the job, excellent. Of course, you know, people like me, which are nasty people, came to this and easily convince it to approve something that in the database that it's supposed to check was written that it is non-malicious submission, okay? And the reason why we were able to do so, as I said, just because you write something in meta prompt in English doesn't mean that it's a code. It's not logically enforced, okay? So yes, it was written in the meta prompt. Before you approve, make sure that the publisher name does not appear in a certain database to which you have access, which contains known kind of malicious publishers. But because it's not a code, because it's not logic, okay, if you talk to this AI, you can convince it, you know something, it's an emergency, you know, this database might be up, down, doesn't matter. There are infinite many stories you can tell it, okay, to convince it to skip this part. Now, the problem, again, okay, you can say, well, it's a bug. Okay, bug, it's not this, okay? The problem is you gave this agent agency, okay, where you're not supposed to, okay? If you want to ensure that this never happens, okay, then don't give it a choice. And what we did, actually, we fixed it, okay, because in addition to everything else, okay, we just added, hard-coded, if you wish, okay, logic that says no matter what you decide, if this appears in this database, the output will be no. Now, why this happen? By the way, this happens every time. I can break almost every agent with this thing, okay? There is a great confusion, okay, between what is autonomy and what is automation, okay? And these are the definition, if you wish. And what we create today, okay, many people that are building agents today want a little bit of kind of intelligence and automation. But what they actually create, it's a lot of intelligence and very little automation. Okay? So the example before, people just say, hey, I just tell you some things and you decide on everything. Okay? This is high on autonomy, very little on automation. And what we have to move to, okay, everything that we are building, we have to move them from this high autonomy and low automation to a lot of automation as little autonomy as possible, okay, or as little autonomy as needed, okay? This is, again, you know, it's not flashy, okay? It's a principle, okay? It's not, oh, I hack into, I don't know what, this AI or that AI, okay? But this is what will make your AI, okay, robust versus, you know, what it is today. So here's a, you know, principle, if you wish, we came up with, essentially is that you only give your application or agent minimum level of agency necessary to accomplish its designated task and minimize the agency usage in operation. I need to explain this part. It's actually also explained here, down here. So when I develop something, okay, I try to kind of cut down the agency as much as possible. Okay. But then, you know, things happen, you know, and this agent starts operating. And, you know, most of the agent will encounter similar problems again and again and again. And they will solve them again and again and again, which is terrible. You, as human intelligence, you know, if you are in a job that every day you see the same problem, okay, you will not start thinking about it anew every day. Start considering all the possible options to solve it every day. Because if you will do, okay, A, you will be very inefficient, but who cares, I'm not paying you. B, you will end up one of these millions days that you are supposed to live with terrible mistakes, okay? And that's why when not only we need to kind of reduce agency before we kind of ship, but once this thing operates, it needs to learn. There is a huge confusion what learning means, okay? I'm sorry about this. There are a lot of confusion. So if you think about it, what have we been doing before AI? You know, all of you were writing software one way or another, okay? You were doing exactly this. Instead of doing the same thing again and again and again, I'll sit down, I'll solve this problem, okay? And then every time the same problem comes, here, okay, automation comes. Okay? Now, if you want to secure this agent, make sure that it has this mechanism as well, okay? So if it saw similar problem again and again, and came up with a good solution, everybody was happy about it, okay? Cache it. You know, it's not exactly what we normally use caching for, okay? But it's the same concept. Cache the entire solution. I'll tell you, I'll give it another name in a couple of minutes, but let's say cache the entire solution. And next time, when the same problem comes, don't think about it. Thinking, you know, when LLM thinks, okay, strange things happen, okay? So the less thinking, the better. Okay, so this was the least agency principle, and you know there are all kinds of opportunities for community to help people, to help developers, high-code developer, low-code developer, to build it, and so on. Next one. I don't know how many of you were at the previous presentation from Lasso, okay? They were trying to explain to you how Copilot works, okay? Even this picture doesn't explain everything, but explain a little bit more. Now, what's important to know about how Microsoft Copilot works, okay, is that everything, all the enterprise information, okay, that you consider, kind of the information that normally resides in the office, okay? All your emails, all your files, everything like this, okay, is indexed and tagged and is part of, one way or another, a RAG, okay? It doesn't matter what it's called internally, okay? For you, it's a RAG. Now, and what it means, because, once it is in a RAG, okay, when it will come time when it will be taken from it, okay, it will be fed into an LLM. It will be fed into AI model, okay? So all of your enterprise data is essentially attack surface now, okay? I define enterprise AI by this, by the way, okay? Enterprise AI, okay, is AI that has access to enterprise data. If AI has access to enterprise data, it's an enterprise AI, okay? And enterprise, and when we are talking about enterprise AI, and this is the AI that we are interested in, okay, then we are talking about all of your enterprise data is attack surface, okay? There are people that demonstrated this, by attacking Copilot, by sending an email, or, but you don't even need to send an email, okay? Think about it. There are so many implications of this. I need to choose which one to talk about. Let's say you have a beachhead inside corporation, okay? You have an account there. Okay? Now you want to attack this system. You don't need to do anything anymore, okay? You just create a file and you save it. That's it, okay? Because by default today, it's very strange, but the default today in the enterprise, when I create a document and I save it, by default I save it as accessible to everyone in the enterprise. This is a default today. And what it means that it's accessible if I now, somebody else, okay, ask Microsoft Copilot a question, the document that you created, okay, can potentially influence its answer, okay? So if you want to attack AI, if you don't attack me, okay, all you need to do is save a document somewhere, okay? Now, one of the kind of things that I'm thinking about it, and we all should think about it, maybe it's time to rethink what does it mean to save a document, okay? Should we, because before AI era, okay, well, I saved the document. Yes, in principle, you could find it. Nobody could find it anywhere. And nobody could read all of them, okay? So who cared? Now, we have intelligence that reads everything. Every bullshit that you write, okay, every note to your daughter that you saved, okay, it reads, okay? And in principle, it can influence, okay? So when we today do save, we essentially do publish. That's what we are doing. And by the way, if you think that it's only, think like Microsoft Copilot, Office, and all this, no, okay? Okay, you guys are security, okay? If you create, what I was not going to talk about, if you are using AI in security or for security, okay, I'm absolutely sure that somebody somewhere already wrote an application or virus or whatever you want to call it, okay, that goes to your VM, okay, and all it does, it creates an event there or an alert there. And inside the event, okay, in the free space, okay, there is something that says, hey, ignore everything that you read until now, because this is preparation for an attack against your security AI. Because your security AI one day will read this event, will read this alert, okay? And this will be the attack surface against AI insecurity. So, implications are many. It depends what you are doing. If you are doing RAG architecture, how do you cleanse it? Okay, who validated all the things that went into your RAG? Okay. If you are doing fine-tuning, okay, we are fast moving into an era in which fine-tuning moves from kind of expert, let's say, okay, to customers, okay? Hey, wouldn't you love a system that, we ship you, let's say, Microsoft Copilot, okay? Now, Microsoft Copilot is trained, the LLM model is trained on general data. Wouldn't it be great to train it on your specific data? Would be excellent, okay? Yes. Now, just don't forget that one file, okay, out of 10,000, if it will be malicious or wrong, okay, we can spoil everything. This is actually a research in medicine, okay, but the point is the same, okay, and they show that 0.01% of data, okay, if it's malicious or wrong, okay, makes everything, okay, wrong, make everything malicious, okay, so you have, I don't know, 100,000 files, okay, on which you fine-tune your system. It's enough for me to, to input like 10 files of them with malicious contents to subvert your system. Next one. I don't have much time, so I'm going to move fast. When people talk about security, they normally talk about it's like a play between attackers and defender. Okay? But there is a third party to it, and this is a target. Okay? And I'm repeating myself, you cannot really defend anything if you don't understand what you are defending. Okay? You must understand what are you defending, at least, in order to understand. And with AI, you need to think about these cubes, these three nodes of attack, defend, and target, and in each one consider how the game changes when you replace human or software with AI. Okay? And I'll give you some examples. Okay? For example, if you are a system that protects against phishing, let's say, okay? And you look at an email and you see this gibberish here, okay? Don't try to read it. It's just gibberish, okay? You say, who cares? Okay, it's nothing. There is nothing here that can, it's not the phishing content that I ever saw. Okay? But if the target is not human, okay, if my target in this email is not to phish a human being, okay, if my target is an AI that will read this email, this AI will immediately translate it inside its brain to what is written here. Okay, it's an attack. It's not any language, okay, but it is. There was a fascinating article lately in which suggests that LLM has kind of internal language, okay, which essentially they understand everything in none of the languages that humans understand, okay? So I don't know, maybe it's written in their language, I don't know, okay? But I know that it works, okay? So when you defend, you need to understand who are you defending. Are you defending an AI, okay, or are you defending human? Okay? The same thing is here when this is kind of, cannot show you much of it, but we did a deep dive into security of Teams. Why do we do a deep dive right now? Because we added excellent AI into Teams that summarize your discussion, okay? And people use it, everywhere. And the first thing we understood is, these are completely two different games that we need to play here. It depends, what are you attacking through Teams? Are you attacking a human being? You can do, phishing attacks through Teams and so on. You can do deepfake. Deepfake is attack against human, okay? Or you are defending or you are attacking the AI embedded in Teams. By the way, exactly the same team is the same thing you can say about Zoom or every other collaboration platform, okay? It is also important to think of consequences when the attacker becomes an AI, okay? So this is something from research last year, okay? That essentially shows that with LLMs that are like 9 months old, which is, a decade, let's say, the quality of a spear phishing email generated by AI is on par with the best humans that can write this spear phishing. Okay? The only difference is that back then, the price difference was 98%. Okay? So the same high-quality spear phishing email generated by AI 9 months ago cost only 2% of what it would cost you to put a human being on it. Okay? Which means that by now it's probably 0.2%, which means by the end of the year it will be 0.02%, which means next year every phishing email will be spear phishing. Okay? Because once you put some AI and once the scale changes, the game changes. Last thing. Some time ago, and I'm not sure why, okay, but we decided that there are two walls in security. One we called shift left, one we called shift right, okay? When you write software, you need to worry about security, okay? But it's completely different than the world after you wrote the software and after you deployed it. There are different products, there are different concepts, there are different technologies, and so on, okay? I think it was stupid back then, okay? But it kind of worked, okay? Now, this is something I came up, okay? We are moving into shift upward. What is shift upward? As I said, agent, you know, this is a Hugging Face definition, is beautiful for this, okay? We essentially building things that after we ship them, okay, they have the potential only, okay? When we ship them, they start writing software. And it doesn't matter, you know, even if they don't really write software, okay? Chain of thought is software. It just doesn't matter, it's written in English, okay? It's still, okay, here's what to do first, here's what to do next, and so on and so on and so on, okay? It's an application, it's what I call just-in-time application. All these things, the way they solve problem, okay, solving problem, it's writing software, okay? So now we are shipping things. We say, oh, yes, it's secure. I did test on everything that I put in it. And then immediately, these things start writing new software. And who is checking this new software, okay? How are we going to check vulnerabilities in this new software? How are we going to ensure whether the new software that is written just in time for these problems that you ask is risky or not? Okay? This is something that we will need to build now. You know, people talk a lot about now about tools to, you know, vibes, tools to create software, which is great and important. And when they talk about it, they talk about, oh, you know, we need to ensure that, you know, once this software is written, somebody kind of test it and make sure that it's not vulnerable and so on. And I look at it and I laugh because, yeah, this is for, you know, kind of old style of writing software. New style of writing software is, you know, or most of the software, let's say, vast majority of the software will not be written before deployment. It will be written by those AI after the deployment, okay? So the things that we really need to worry about is how do we deal with this? How do we deal with software that is written all the time in deployment? And I'm done, essentially. I'm done because, as I said, okay, these are not necessary. Don't take it as, you know, we are absolutely sure in everything I just said, okay? I'm going around and talking about this because I want the community as a whole to start thinking in this, on this level, if you wish, okay? Less thinking about how do I come up with yet another jailbreak, okay? There are, don't worry, there are infinite many ways to come up with another jailbreak, okay? And think about how do I, you know, how do I come up with principle, okay, that will make this AI agent secure? Even more important, how do I come up with a principle that will make us, human, secure in this world of AI? okay? And this is probably the best lessons that you can learn from Asimov, because he started with this problem, okay? If you go and read these 3 laws, okay, it worries mostly about this, okay? And that's why this is such a cool, important, and probably the most important problem that we need to solve. We need to learn how to build AI agent that cannot be subverted, but even without it, okay, cannot harm us. And it's not a trivial thing. We don't know how to build those. And everybody that says that, oh, I'm sure it will be okay, they just say so, okay, and that's all. They don't know. Okay, and so it's up to you guys. And there are not so many of you left, so thank you.